Okay, today we're going to talk about, we're talking about z-scores, and this is page 64 of the notes. It's page 64 of the notes, and we're talking about z-scores. And z-scores are a ratio that tells you how many standard deviations a value is from the mean. And truthfully, that probably doesn't make a whole lot of sense, so let's go ahead and take a look at the formula. There's a couple of formulas that measure this, but we're only going to worry about one for right now. We won't worry about the other one until November. So z equals x minus mu over sigma is what we're concerned about. Z is the z-score. Now we have some symbols that we should be able to recognize right here. We have mu, which is the mean of the population. So this is the average, the population's average or mean. And this is the population's standard deviation, all right, the spread of the data. And x is an individual value. So basically, you're finding out how far an individual value is from the mean, and you're making it in a ratio by dividing it by the standard deviation. So a z-score just says how many standard deviations is a singular value from the mean. So because we're subtracting, we can end up with positive z-scores or negative z-score. A negative z-score means it was less than the mean, so you're below average. A positive z-score means it falls above the mean, so you have above the mean, so you have a positive z-score or your multiple standard deviations above the mean. Okay, now we use standard deviations for a bunch of different things. For instance, typically speaking, we almost always say a value that's 3 standard deviations above the mean is an outlier, and almost always say that a standard deviation below the mean is an outlier. And for AP stats, we generally just say, you know what, within 2 standard deviations above the mean, 2 standard deviations below the mean, if it's outside those parameters, we generally call them outliers. Now, the cool thing about a z-score is you can use it for any shape distribution. You can use any shape distribution, and that's pretty cool. All right, so it doesn't matter whether or not it's skewed or normal or uniform. We can use a z-score, and then we can compare other distributions. All right, so if you're curious as to which course had a harder final, such as like chemistry or calculus, which is 2 different classes, you can actually use this as a ruler to make a comparison. And I'm so glad you asked about chemistry and calculus, because we're going to look at a couple chemistry and calculus finals and see where the student performed best. All right, so this allows us to make comparisons for different distributions and different samples and compare them. And here we go. So at a college, the scores on the chemistry final are approximately normally distributed with a mean of 75 and a standard deviation of 12. Well, just for organization purposes, I'm going to write that down. So we have a chem final, and we happen to have a mean of 75 and a standard deviation of 12. The scores on a calculus final are also normally distributed. So on the calc final, we're normally distributed with a mean of 80. So the average is a little bit higher, and we have a smaller standard deviation in this case of 8. Well, we have a particular student who scored an 81 on the chem final and an 84 on the calculus final. Now, it turns out this student is very, very interested in his class rank, and he wants to know, hey, which course is helping me or hurting me? So he was very interested to see how he did relative to the other students in the class. So how did his scores compare from each class? So this is where we can use the z. So z equals x minus mu over sigma. Well, we just defined the mean is 75 and the standard deviation is 12. So I'm going to go ahead and plug those in. Minus 75 over 12. And we said that he scored an 81. Well, 81 minus 75 is 6. So in this case, his z-score is 0.5, which means He's a half standard deviation above the mean, 0.5 standard deviations above the mean. And then on the calculus, we have x minus mu over sigma once again. And we know that the average was at 80. The standard deviation was 8. And he scored an 84. And we end up getting z equals 84 minus 80 is 4 over 8, which is 4 over 8, which is 1/2 or 0.5. So in both cases, he scored 0.5 standard deviations above the mean. So which one did he perform better on? Well, obviously, if in both cases there's 0.5 standard deviations relative to the other students in the class, he scored equally well. So he scored equally well Now, some of you are sitting there going, but he scored an 81, which is lower than 84. And that's true, but relative to the other students in the class, so for class rank purposes, he scored equally well. He scored equally well. The next one. What would a 60 on the chemistry final equate to on the calculus final? Well, that's a good question. So once again, we're going to go to z equals x minus mu over sigma. And we're going to work with chemistry first. All right. So we know that the mean for the chemistry was 75 and the standard deviation was 12. And it turns out this guy made a 60. So I'll put a minus sign there. There we go. So how did he do? Well, first off, he didn't score so well. He made a 60, but we went z equals negative 15 over 12. So z equals negative 1.25. So basically, he scored 1.25 standard deviations below the mean. All right. Well, how does that compare on the calculus final? We know on the chemistry final, he made a 60, so he didn't do so hot. But how was it on the calculus final? Well, on the calculus final, we know that the mean on the calculus final was 80. We know the standard deviation is 8, and we want to find out what a person who's 1.25 standard deviations below would have scored. Because the guy's running around and saying, well, chemistry is so much harder than calculus. So let's see if they're telling the truth. So I go 8 times the negative 1.25, the z-score that came straight from here. And then I add 80 to it, and I get x equals 70. So as it turns out, a 60 on the chemistry final is equivalent to scoring a 70 on the calculus final relative to the other students in the class. Okay, the next one I'm going to do, I'm just going to talk through, and I'm going to talk through it on the computer screen, but there are a couple things I need to change, all right? First off, it says with a median income, change that to mean, and also change this one to mean, all right? And then I want to talk to you about the table real quickly. So the table below describes the distribution of median income and mean income in the 50 states. So we find out that we have 50 states. The average income is 51,742. The standard deviation is 8,210. We have a minimum of 36,000. 25% is below 46,000. The middle, 50% is larger and 50% is less. The median is 50,000. 75% earn less than 57,000, and the maximum value for any single state was 71,836. We had a state that had an average of 71,836. And I'm going to try to share over really quickly and talk through a screen. Apologize for the brief delay. Hopefully it won't take that long. Okay, so hopefully we're looking at the screen that has the chemistry page on it. I mean, not the chemistry, but the z-scores for North Carolina. It says find and interpret the z-scores for North Carolina with a mean income, because we changed that, of 41,000. Well, I write my formula, and I know that the average for all states was 51,742, and the standard deviation was 8,210, and North Carolina had 41,553. Well, what that means is North Carolina, when we calculate the z-score, was 1.24 standard deviations below the average. And we knew that we expected a negative z-score because their value is below the average. So we would think that we'd have a negative, and it turns out we're 1.24 standard deviations below the other states, or the average of the other states. Then we go to New Jersey and we say, hey, we have a positive z-score, so we would expect them to make more on average than the average of the states, which is 51,000. And they ask us to calculate that out. So we have our mean, or the average of the other 50 states, the standard deviation of the 50 states, our z-score, and we solve. So 1.82 times 8,210, add the 51,000 to it. We end up, sure enough, being great at 66,000, almost 700. So 66,700, which is greater than the 51,000. And we anticipated that we'd have a positive value greater than 51,000 because we had a positive z-score. All right, that'll take care of us on z-scores.